anatomy and physiology and got a C 10 years ago, then they're like, oh, that still counts. We won't count it. Like you need to take it again, but it still counts. I'm like, you need to pick one. Either
It counts for
it counts or it doesn't. So anyways, so I wrote a couple things on the board that I want to go over, but I also like don't want to ask all the questions. But these are a couple things.
That is why we're here.
Or whatever, wherever you want to go. I was just looking at stuff like shit. I don't remember.
Good morning, Hava.
Good morning.
Let's just be one.
So
That's why we're here. She worries.
I noticed that over there on that board, that's where markers go to die. So just just a question. I think I'm convinced it's the something, some material. Probably like oil, some oil. That stuff we can kind of, those are my notes.
Are those questions on the final study guide?
Yeah.
Oh.
Yeah. So the ones that are similar for E and F are the same as like this type of question. It's like the frequency.
Oh, where it says it's like 10 math units apart.
But that's
Isn't it like the closer they are, the more?
The closer they
Or is it-
are, the least.
Or is it like farther there to? Or is it farther? It's farther apart?
part of it. Yes. The way I think of it is that this is, so we have our chromosome and the homologs. Let's say we have genes A and D. So both of these things will reproduce or not. So recombination or crossing recombination or crossing over is, random as far as we know where on the chromosome it happens. So if you have genes A and D and recombination can happen at any point on the chromosome, let's say you pick a random one here, recombination happens here, then what we get is we have recombination here, then these two would be switched over. All the genes and alleles in front of this chromosome. And what we see is that they're the same as the parent from before they crossed over. So these were non-recombinant in this instance.
For those genes.
Yes. Why do you think that is?
Why they're not. It's so too close together.
Yes, exactly. If we chose any random point on these chromosomes, genes that are close together are more likely to remain together. And because they're so close together, you'd have to have like a really specific point of crossing over for any actual.
Which doesn't happen. I remember with NAR saying something about this in minor reviews. It's like it would take more energy than really worth.
Yes, it's confusing to think about it that way, but you have to keep in mind that these are like molecular processes and we have machinery that actually like engenders this to happen. So
I think it's like naturally. Like if you were to think about this in like an organism. I don't know.
I don't know if that's a good thought.
That it's like because they're so close together and you're saying that a specific crossing over needs to happen, it's just not worth it for the organism to do it.
It's not intentional. No enzymes in a cell have large isn't trying to get this to
Yeah.
crossover. It's just a happenstance event that could possibly create some genetic variation. So what you have to realize is that it's not just A and T. There's 2,000 other genes on this. We just simplify it for the sake of it.
It's a probability.
Yeah.
That's what it is. 'Cause I think of, I know the gene for freckles and the gene for red hair, from what I've heard, are close. I don't know if that's true. But in my head, I think about that.
That would
I'm
be
like, they're
so
so close, so that's why you see a
See
lot of
them
redheads
together.
who have freckles. I have freckles, but I don't have red hair.
That's
But yeah, that's how I kind of think about it. It's so silly, but like it's just silly thing to stick.
That's the thing, it's like silly things to say.
Yeah.
But yeah, the closer they are together, the less likely it is that any random recombination spot will separate two genes from each other and cause them to be recombinant, unlike the parents. I don't like to say that. So on that note, what is-
So I think the question is, it's something about the
And we might have
recombinants, if they're 10
questions.
macrolins apart.
Okay. And we had another question on 2C as well. Okay, non-destruction, absolutely. That's a tough one, but we can do it.
It's actually not tough. It's really comprehensible. But which one did you want to do first?
We can do the mapping one. I'm sorry, which one did you? Took them out of order, sorry.
This one next. This one, okay. So
So there's the. One second, so sorry. So question number 4, it's basically the same question, but the exam, I just copied the exam question. So you have the exam and then the practice. That was from exam 2. Sorry, not right there. So whichever one you think is better as far as reviewing.
it's not a good thing. Could you say that one?
I'm sorry. So I pulled a couple questions from exam 2. That one's from exam 2.
Okay.
It's asking the same thing, but it's
That's the one.
presented differently on the sample final. So I guess maybe let's go over this question E and F here because it specifically says when it's in a coupling confirmation and a propulsion confirmation.
I think that's just testing like your vocab knowledge. As far as
It's-
coupling. and propulsion.
Yeah, it's can we do that one?
No, yes.
Oh, okay.
We can do that one. Let's hit this.
Okay.
So gene loci A and B are 22 map units apart. What are the correct frequencies that this fly could make? That wasn't the exam.
That's on exam 2. And I don't know how I got it right, but I did.
I
completely
genuinely
forgot.
don't remember that question.
Like,
Gene loci A and B are 22 map units apart. So if they're 22 map units apart, what does that tell us?
That it's far enough apart. Well, that means you have 22% recombination.
What are the correct frequencies that this fly could make?
Huh?
I don't understand what it's asking. Oh, like what are the
Number of recombinants. Frequency of recombinant.
maybe like the proportion of offspring? So maybe it's just asking all of the different frequencies of all the different possible genotypes. Okay. Gene loci A and B, what are the parental genes?
oh, the parental genes are uppercase A, lowercase b, and lowercase a, uppercase.
And if they're in trans, it's right there. Sorry. Sorry, I just didn't understand the graphic, but
Yeah, I'm sorry. That's what was on the test. And I was like,
that's
Yeah,
confusing.
I couldn't tell what, like, was it AA or BB or was it AB? Okay, now I understand.
So if these are our parents, what possible offspring can they make? Knowing the pairs and traits.
so they can make capital A or dominant AB.
Big A, little B. A, big A, little b. Just, the same as the parent. Little a, big, little b. The same as the parent.
This would be the non.
Yeah, yes.
Yeah.
So the possible. So what we have on a chromosome. Is this distance.
Oh, okay, the graphic on the exam makes a lot of sense. This is like this thing.
Okay, yeah, that's what I said.
Sorry.
Also, I also do not know how I got that one correct.
Because you guys are smart. How dare you keep doubting
Well, it's like
yourself?
I definitely knew the information
We
at
knew
the
this
time.
a couple months ago. But if I need to know this today.
So this is the distance. And they're 22 math units apart.
Super to scale.
And that means that on 22% of occasions, they're 22 math units apart. What does that represent? You said it.
The percent recombination.
Yeah. 22% of the offspring display as being recombinant relative to the parents because of the distance between the genes on the chromosomes that are constant. So it's business, and that gives us A. As well as the line. So these are our, oh, that's not right.
Oh, that's right. Like that would be the, yeah, that sounds about right.
Those would be the.
Those would be the recombinants. It's just
Oh, yeah.
funky because they're in trans.
Don't get confused with that. So trans is simply referring to, you know how you have like molecule alkene and it's in the E confirmation. It's in trans because you have the two like substituents
On different sides.
that are on different sides of the double bond. And so when we think trans, we think across, yeah, and cis is yeah,
Or the other.
around the same. And when we're talking about trans and cis allele conformations in genetics, we're saying that this one is on a different side than this one. It's just different because it's not capital and capital like you'd expect. It's one is different than the other. Kind of like if you had a wild type versus an individual with two wild type alleles, you'd expect that they have this, and that would be in cis conformation, but sometimes the parents have
Repulsive allele conformation.
They had a question on 2C.
So we will get to that in just one second.
Thank you. So 22% fall into these categories.
Yes. And that's how we would get. That's how we would get 11% retrospectively.
Yeah, because we assume that it's just as likely that, yeah, the math works out.
Okay.
So you take 22 and you divide it by the possible genotypes that you can get.
Got it.
So does that make sense? If we have, if there are 22 math units apart,
Do I do something?
because there are two possible outcomes.
That makes sense.
So we're told that distance apart, and because we use distance to approximate recombination frequency for this reason.
Okay.
we use their distances to approximate the number of offspring that will show up as recombinant, or get recombinant relative to the parents. And so we have our frequency. But there are two possibilities, two like things that fall within that category of being recombinant. So we just divide by two to get the individual ones for it.
Okay.
Wasn't consistent with my colors. So,
No, it's okay.
so
That makes good sense. I just don't remember.
it was a long.
Got it.
This was chapter 7, and I think chapter 7 was exam 2.
Oh, yeah.
It was back in like October. It's December now.
Okay, I think I'm good on this one. So I can figure out the other non-recombinants. That would also be. Oh, that would be 38 lab units. Because it's a non-recombinant, so maybe I did some funky math, but I did 1 minus 0.22 and divided it by 2.
Well, the answer was 39%.
I trust.
Or 39 math. Yeah. Okay, man.
Which other one?
Which other one what
Which other genotype?
would be 39%?
The one to the left. I'm sorry. I'm sorry.
No,
It's just a non-recombinant.
Yeah. Yeah, which is consistent because non-recombinants always have like the highest.
Yeah.
Oh,
why?
because it's really hard to
Do
have
it.
recombination.
Yeah.
Yeah,
It's
it's
unlikely. There we go.
Also another question on the final study guide thing. One of the questions where it was asking about for you to find the math units, I think it was this one. She said that she got between N and E 7. I don't know how she got set. I figured out that, like, I understand how to do the math, but I don't know how she got set.
So it's that single crossover. Crossover 1 or 2, I guess. We can. Do you want to do that? That's just 3-point crossover.
Yeah.
No problem. Absolutely.
So 2C, don't want to keep them away. What happened?
Oh no, it is no trouble at all.
I can erase that too if you'd like.
Would you like to? Oh,
This is for them.
when are genes linked?
Oh, when they don't have the combination.
Yeah, I think it has to be completely zero, like recombinants.
Yeah.
I'm not sure if it has to be completely zero, but yes, that's the idea. The closer they are together, they're so close that you can pick any point on the chromosome and it's almost impossible to like separate them from each other.
Okay.
And it's a spectrum. You can go from like completely, absolutely, entirely like the genes are right next to each other.
Yeah.
Or they could be gradually further apart. And that's how you get the 20, 30, 40% recombination frequencies. What happens after 50%?
No.
It's not a very accurate number. Like, I mean, not accurate number, sorry.
Because the genes are so far apart, like you can't calculate how much they recombine.
You like lose integrity of the number because it could very well cross over multiple times and you don't know, and you interpret it as a non-recombinant.
Exactly. Anyway, the maximum percent recombination frequency is 50% because pretend that's it. When you have 2 chromosomes, the maximum number of arms of the chromosome that can cross over, say that these 2 cross over, is 1, 2 out of 4 arms. So 50%. So a maximum of 50% of genes can cross over at once relative to a chromosome that has only 1 homologous pair. If you're like a plant and you're a triplet, then it wouldn't be 50% maximum. These 2 could also cross over together. 4 out of 6. A triploid would have a maximum recombination frequency of 0.66. And a tetraploid have 6 out of 8, which is 0.75.
Okay.
Did you catch that?
No.
The reason why the maximum recombination frequency that we usually think of is 0.5?
Oh, because we only have 2 chromosomes, typically.
Yeah, typically we only have 2 chromosomes and only these 2 cross over with each other. Then it will make 1, 2 out of the 4 arms of the chromosomes. are constant. But as you add more homologous pairs, that can increase. Let's go into maximum frequency. Yes, you're right. And further like above, like we can't really measure past 0.5 because it could be that they're so far apart from each other that like almost any point on the chromosome that you select will see them recombine, will see them cross over, or they could be on entirely different chromosomes. And of course, they can cross over that way.
Yeah.
They won't be linked because they're not touching. So that's that.
Yes.
Auto, allo, polyploidy.
What does the word auto mean? What do you think
Think
of?
of when you think of the word auto. Oh, so I think what's the German word for car? But, I also think of autoimmunity, autoimmune disease. And an autoimmune disease is when your immune system attacks yourself. So auto polyploidy. Do you remember what polyploid means?
Many.
Multiple sets. I know it's multiple sets of chromosomes.
Where have we seen ploid before? Yes, you're perfect.
Diploid, haploid.
Yeah, you got it. Ploid refers to the chromosomes in our body. Poly means many. We're usually concerned with diploids because that's who we are. So we have 2 chromosomes that represent all of our genetic information. But a polyploid typically has more than 2. Technically, this is still polyploid because poly means many or multiple. Yeah, multiple. But polyploid event is when you have a condition like this, but through something like
Trisomy X or something like that.
what is it?
Non-disjunction.
With like non-disjunction, you can have like entire genome duplication events. No, but yes, for a specific chromosome, not like all of the 23 chromosomes. Just their sex chromosome, but that's a good idea. Yeah, so you go from 2N to 4N in a single meiosis event, and that is a polyploid condition. But where this happens affects whether or not it's an auto or allopolyploid event.
It's a perfect segue into 2C, where did disjunction occur? But before we get there, one quick question. Through some of the old tests and practice questions we had auto/allo polyploidy questions where it's like, if you took species A and B, like what are all the possible chromosomal, what are all the possible number of chromosomes?
Yeah.
I
Were you
guess.
talking about this question where it's asking like 2 species hybridized and then form an allo tetraploid?
Yeah, I think I might, like, that's pretty much it, right? Oh. That time of year.
Yes, hybridization. That's my favorite word. Where does that go?
Hybrid, what?
Hybridization.
Yeah.
That describes allopolyploidy.
I just did.
Oh, yeah, no, because allo, it combines 2 or more species. It doesn't have
Oh,
humans,
because
but
auto
it's
means
like,
self, so it'd be like you have multiple of yourself.
what, do you have a species example?
I do.
Does that-
Helianthus.
Yeah, this
Oh,
one
what?
is Helianthus.
Oh, the same one.
nautis, And this one is
Weren't you good?
Helianthus of Rank.
Oh,
So it's like
it's a
2 different
sunflower.
types of sunflower. Okay, cool. Makes sense?
Oh my God, so is this like when we bred the Florida puma with 2 different subspecies?
That's a great.
Okay, you were like, I'm getting somewhere.
Yeah, I'm like, oh.
That's the reason the reason that those two like were so genetically diverse and came to increase the heterozygosity of offspring in their
Mhm.
population is just because of simple meiosis. They were different enough to like create some more diversity. that
Okay.
could aid their population.
But the argument is, are they still genuinely sort of twins?
My opinion on that is, does a panther know that it is Panthera floridania subspecies alba?
Mm-mm.
No, it doesn't matter. Not to them. It doesn't. The sciences that we humans create don't affect the natural world. Plants will still grow their roots. The sun will still shine. So there is no like natural, actual, real distinction between subspecies and other subspecies.
I think you'll really enjoy it. If you take conservation biology, you'll open up your eyes to a whole new world. Like,
I really want to.
you should. Okay, sorry, I digress. Very interesting though. A lot of fun. When you understand what's going on. Whereas when we have like what?
No, you can teach me.
It's fun.
This
Okay.
business. Helianthus. The reason it's not Florida panthers is because animals are not, they're not as competitive as plants are. Plants are Earth's superior organisms. If you cut me in half, how well would I do? But if you cut a plant in half, it's gonna grow taller than ever. You could burn a plant to the ground. You couldn't burn me to the ground. I wouldn't go back. But plants
Oh,
That'd be
no.
spectacular if you did.
That would be fantastic. But another thing that plants do that
United
makes them amazing is that they can have these genome duplication events. Are even more competitive. Sometimes it's detrimental, but often these gene duplication events, like entire genome duplication events, make them bigger. They can produce more seeds. Bananas. Yeah, they
Bananas.
make bigger.
They're more
fruits.
genetically
That's
diverse.
bananas. Sorry.
Door. Get out.
Yes, but where this happens determines whether or not we're auto or allo polyploids. I think of allo, I remember back to AP biology so many years ago. We were talking about allopatric speciation. Patri means father, speciation, creating species. So allopatric is species that happen during or from different father lines, patri father. That's just how I remember it. That's a dumb example, but allo means different. Long story short. And auto, as we discussed, means self. So if we have someone in meiosis, let's say they're in meiosis 1. Where can you see this? Let's say we have meiosis 1. We're on to 2C kind of. Except not actually 2C, we're just talking about non-disjunction for now, but we will answer 2C. So meiosis 1, we have our prophase, and let's say we started out as 2n equals 6. From that phase, they align in the center. And the phase, we still 2 equals 6, but we
In anaphase,
in
2n equals 12.
No,
No, I'm sorry. Or in my meiosis 1. Oh, okay, sorry. We are still 2n equals 6.
because we just, what do we do in meiosis 1, in the phase of meiosis 1?
Well, it's like in metaphase, they line up not in a line, but in like a square or a rectangle.
Yes.
In pairs.
In pairs. Yeah, exactly. So in the anaphase, we're just separating the homologous pairs from each other, but they're still like in the cell. And then telophase, they start to migrate apart. But
Dumb question. In telophase, are we still counting them as 6 chromosomes?
this is a good question.
I think so, yes.
I do.
Because it hasn't complete,
cytokinesis is
you
what
haven't completely split yet, so
Okay.
it's still one thing.
Okay, I just had to double check.
Because I remember like seeing something that was like cytokinesis quite literally means splitting the cytoplasm. So it's like, I think that is like the final step where they've split into two,
Cyto means cell.
and until then, there's still one.
Yeah, and consists of like kinetics, movement. So the movement of cells apart from each other, and only then when they move apart from each other. Separate cells were under chromosomes as being separate. What is the ploidy of either of these cells?
Meiosis.
Per? Oh.
They were just separated from each other, homologous pairs. They were previously.
Okay. So we would have had 12 chromosomes in the beginning, sorry, in prophase, metaphase. In anaphase, we had 12 chromosomes. Telophase, 12 chromosomes, 24 molecules. At anaphase, telophase, we'd have 12 chromosomes,
24,
still 24, it doesn't change.
because the cells have been split.
Yeah,
So then it'd be 2 n equals 6. Or, sorry, n equals 6.
okay, at which I think was 6 chromosomes. Yeah, I'm definitely drawing this out.
I always draw it.
I was gonna say that. So when I was doing the review, for some reason, I could not figure out why that here in, when she's talking about metaphase 2 of meiosis, I was like, how is she getting 4? It was just bothering me. And every time I drew it out, I was like, I'm getting a different number. And then I was like, that's like, trying to plus it. It's like,
Yeah, I stared at that. That took me too long.
I was like, it's because they don't split evenly.
Yeah, yeah.
What's this? What's the purpose of meiosis one?
To create haploids. To make it n instead of 2 n.
Yes, and how do we, like, what is the mechanism for that? What? What kind?
I don't know.
It's
I
not-
know the purpose of meiosis in general is to produce 4 unique haploid
Yeah, like
cells.
to create genetic diversity.
And how do we?
Through crossover.
What I was
What was
getting
your
at
question?
was, like, what was the purpose of meiosis one generally? What does meiosis one do to set up meiosis two, which gives us our ultimate result?
You're making 2 cells.
You're,
You're making 2
separ-
haploid cells.
you're separating homologous chromosomes from each
Oh.
other. It's not that deep. It's not that deep.
Why I need to stop reading into everything so deep. I can't help it. Good thing is I feel like a question like that would hopefully be a multiple choice question.
Purpose of meiosis one is to, like, we're trying to do exactly as you said, make haploid daughter cells that are unique from each other. And the way we do that, starting with the parent cell, we have to reduce the genetic information of the parent cell. We do that by first separating the homologous chromosomes from each other. What's the purpose of meiosis two?
To create the 4 I-O-S-I-S.
To create the four. How do we create the four? Kind of, honestly. Do we even know chemistry is real?
No, it's
It's
made
a
up.
lie. It's all a lie.
It's literally made up.
It's a lie. We can't even see this stuff.
Exactly. So meiosis one was to reduce our genetic information by separating homologous chromosomes from each other. How do we reduce genetic information?
It's haploids, right?
What is the difference between a haploid and a diploid?
Haploid has 1 chromosome.
Sex. Exactly. A diploid organism has two chromosomes that represent the genetic information at each of the different chromosomes that they have. Like we have 23
Yes.
Yes, we have 23 and we have 2 chromosomes that represent each of our 23. Right. Haploid is when you take that original information, the original amount of information, and reduce it to haploid. So haploid is just relative to the original parent cell, and in this case, it's diploid. When we're creating a haploid cell, we're going to it. Have we not already made our cell haploid by n of minus one? One. How's that haploid?
Because you said,
There's still 6 chromosomes.
but they don't have the homologous pairs.
It's one chromosome. It's no longer.
So they're already our daughter cells. So minus 2 isn't to make further haploid cells because they're perfect. Yes, it's to create gametes. And gamete. How would we describe a gamete?
It's essentially one of the sister chromatids, and when you take 2 gametes, they will fuse
To make a diploid organism.
Starts with a D.
Zygote.
Yeah.
Just like you said, a gamete is a haploid cell where every chromosome is only made up of one sister chromosome.
Gosh. God, I really need to do good on this test.
Honestly, I kind of like the short answer questions because I can be frank and say, I'm gonna be real. I don't know, but I'm gonna explain as much as I do know.
Everyone loves that. Truly.
I love her feedback on like some of the extra credit questions. Like the favorite band, I like referenced an old band, and she was like, I used to like them too until it became mainstream. I'm like, let's see Dr. Bell. You're so cool. I'm sorry. Can we touch a little on the disjunction?
Absolutely, that's true.
Whenever you're ready.
I'm every year.
Oh, no, sir, I'm here. I'm on your time.
No, I'm on your time.
Oh, wait, you can look that. Did you want to? Never mind.
I can reach out.
Okay.
I am on your guys' time. You are not.
Do you have anything today?
I finished all my schoolwork
Oh.
last night. Or technically this morning.
Must be lucky. I have 2 exams on the same day next week.
I had
Right.
a field trip and I had to teach a lesson on Monday. And I had a final, I ordered a final, and I had to present a project on Wednesday. And yesterday I had my anatomy final. And, I'm so sorry. It's
How did the Oreo final go?
I have hope.
Is it order 1 or 2?
One.
Oh, 2 do you have?
I had Greg Petrunccio, the god of chemistry. I
I
love
like
Greg.
Dr. Ward. I love Dr. Ward.
No, Greg is amazing. If you haven't taken Oreo one yet, take.
I took order 1. Actually, order 2.
Okay, I'm so sorry to keep you waiting. Are you still here? I really hope so. Please forgive me.
I'm done with this. Bye.
Oh, there are 4 people here. Hello, hello. Okay, so I'm actually gonna do 2C now. Okay. Where did disjunction occur? Let's. Awesome.
question.
So, can you see the board, by the way? Clearly enough? I can move it up if you can. Okay, fantastic. All right, Baker. Could I see question 2C?
Oh, on the exam? Or
So
no,
this is the practice.
Okay,
I
practice.
got it right.
At least type questions.
Oh, yeah, that's, yes. So there's a question, never mind, we'll get there when we get there. So I know the answer to the disjunction one, but I just need to, like the methodology.
We talked about this, or I talked about this very late at night with Johannes, Linda, and Tanya before exam 2. And we went over colorblind allele. So when I do these questions, I write out what I do. The gene that controls color blindness is on X chromosome. Color blindness
recessive. So colorblind allele is recessive. It's an X-linked recessive gene. And let's say that color blindness B for blindness. You have a recessive condition. You're colorblind.
That's little people.
That's a good point.
I don't know.
I forgot how I did that.
Oh, it says, oh, a woman who's a carrier with a phenotypically normal man, it's asking what is the chance they would have a colorblind boy.
That's where I started. I start with the genotypes of the people in question.
Don't want to make you all different. The genotype is colorblind. So the colorblind allele is recessive with dominant normal vision. Typical. So part A woman who is a carrier for color blindness. She's a carrier. What does that mean? Her genotype is heterozygous. Hetero means different, zygous means your genetic information.
I don't like red.
So we have a woman who is a carrier. A carrier, when I think of carrier, I think of someone who's like a carrier of a pathogenic infection. Like they don't show as having that infection, but it is within them. And similarly, a carrier in the case of genetics is someone who has a genotype.
Well, the marker's dead.
Can you see this?
My head's in the way. Can you see the blue? I'll just use a different color.
Did you want me to put it to everyone?
Oops. Thanks. Okay.
So, in genetics, a carrier is someone whose genotype presents or codes for a phenotype which doesn't show the disease or condition in question, but just like a carrier of a disease that is still within them. So we have this normal B allele that dominates the recessive B allele, which when transcribed in our genome creates conditions for color blindness. Just so this is the woman. Question. Have a child with phenotypically, so they have a child with a phenotypically normal. What does it mean to be phenotypically normal?
Which means that by looking at the person, they aren't colorblind, but we know that they're a male. They have an X and Y, so they would only have the big B allele and a Y.
Yes. So phenotypically normal means that so our phenotype comes from our genotype. So if they're phenotypically normal, it makes sense that they have at least one normal allele.
They can't be carriers. So either they have it or they don't.
And just as Jazz said, this individual is a male. We have to look further into. They're a male, which in humans, the heterogametic individuals are the males. Hetero meaning different, gametic meaning their genetic information. So the alleles that they have available at their sex chromosome are different, unlike females who are homogamy. Jazz said it. We know that they're phenotypically normal, so they have at least one dominant allele that attributes normal color vision to them. But because they're a male, they have to also have at least one Y chromosome. So if these two were to cross, what are the results possible? simple. The mother can either give her, the mother can either give her big B or her little b. Father can either give their big B. Yeah, father can either give their big B or their line. So if this candy, it would be. It would be this one, very simple, we've been doing this all year. You apply. So now that we have all the possible genotypes that can result from a cross between these two, we can just check to see which ones would have the phenotype of color blindness based on what we know about the alleles. So this individual has no colorblind alleles, so they have color vision. This individual has at least one dominant normal color vision allele, so they're at least one dominant normal color vision allele. Well, this person has no dominant color vision allele. They only have recessive color blindness allele. So that one out of 4 is 25, 0.25. And part B, a non-disjunction event led the couple to have a little girl with Turner's syndrome. What's Turner's syndrome?
You only have one X chromosome.
This is the genotype at the sex chromosome, number 23 of an individual with Turner syndrome. They're missing their other X. It was not given to them because of non-disjunction. But how does such an individual continue to live? Gene dosage, our bodies, usually in any the homogenetic individuals of the species, females among humans, we have gene dosage compensation, because if we have 2 X chromosomes, each of these chromosomes are like making something, we like to think. But we don't want to make too much of it. We don't want to overdose on the products of our X chromosomes, so we turn one of them off. And we only, or females only typically use. So a Turner's syndrome individual can get away with having just one, because female humans would usually only have one. But they don't have the benefit of female mosaicism, as you can additionally.
I mean, it's not the greatest, but it's something.
It's
I mean, they still have physical issues and developmental issues, but
exactly because female humans rely on
both
those
X
things. Turn one off if it's not
correct.
giving what it needs. Or there's actually a really interesting argument for natural selection within our own cell, within our own cells, for which X chromosomes turn on or off, and that X chromosome can be selected for in some way to be passed on to future cells that make you more competitive as an organism. So Turner syndrome, offspring is just X. Little girl has Turner syndrome and color blindness. So where did non-disjunction happen? This one is quite easy.
I won't say.
So when we do these questions, we have to think about, what can a parent give? I have a shortcut that uses that way, but we can work it out. So let's investigate the woman. Let's investigate the woman. Use this one. The woman starts off with, stop drawing the X's and just write these.
You're gonna, you're gonna write one.
I'm going to stop writing the X's and just write the B's.
Okay. So the X's throw me off sometimes,
Yeah.
because I'll write X and then I realize, like, I think sister chromatids That's not the
Yeah.
case. Meiosis II.
My brain works this.
Yeah, the big B and the little b, they're in prophase, just hang out. And in metaphase, they align their homological pairs. These two sex chromosomes are homologous to each other.
Okay.
Uniphase, they're typically pulled apart from each other. Do you remember what pulls them apart?
It's the spindle fibers that form, that is actually chemical.
Yes. Or
No, but
telophase, we have our, what is this called?
that is solve the. The cleavage point.
Yeah, cleavage.
Oh, sorry, literally said it, but I like that, the cleaver, now I'm gonna think about that.
That's how I. And we have separation of the two. from each
Okay. Technically, there'd be two copies of each, right? So it'd be like two copies of big B, little b.
other.
I'm just thinking, I'm like kind of thinking fast forward to meiosis II, at which point like they'll separate again.
Oh, that's where I went wrong with this. I didn't investigate.
So when I do these questions, I purposefully make non-disjunction happen at the phase and then investigate
The resulting cells
Okay,
and compare them.
to what we
Got
see to see if they're the same. And if they're the same, then we know that's where non-destruction.
okay,
But if none of the possibilities correspond to this one,
Then we know non-destruction could have happened there.
to create this
okay.
offspring,
So let's say
that non-destruction happened here, what would non-destruction look like?
B, like they would, capital B, sorry, big B, little b would stay on one side and nothing. They'd be stuck together essentially.
Exactly, because in the phase of meiosis I, it's about separating sister or homologous chromosomes from
Yes.
each other. Sister and homologous, so they stick together. Telophase, parts. One side,
no sex chromosomes in another cell. The cell isn't entirely empty. There are still the other 23 chromosomes.
But as far as these low,
That no gap. This would be the result.
okay,
Genotype for this is XAB,
Which is not the offspring that we're looking for.
and a non-genotype is also not the offspring we're looking for. So we know that because the resulting the cells that result from the non-disjunction event we created in the phase of meiosis I doesn't match to the actual genotype we observe in the offspring of concern that meiosis I's interphase did not feature non-disjunction.
How would we know in a question where non-destruction occurred?
Doing this. What I do to figure that out is I look at the parents and I investigate one at a time.
Okay.
And what I do is I go through the process of meiosis, create non-destruction, because non-destruction happens in what is a junction?
Where two paths meet.
Yeah, two things together. What is this? Yeah, so junction is two things together. Disjunction is when two things split apart. Was not.
Not or done.
Yeah, so where we would typically like to have disjunction, where our homologous chromosomes separate from each other, or our sister chromosomes separate from each other, we don't have a separation. We don't have a splitting apart of the two things. And so what we're doing is creating that non-disjunction where our two things don't split apart like they should, and investigating the result. And if the results that we find match to the offspring, then we know that is where non-disjunction happened. But in this case, this is not this, and then not doing that is also not this. So we know that non-disjunction did not happen. So we can move on to what happened if meiosis 2 and another featured non-disjunction. So assuming that meiosis 1 went off without a hitch, we would end up with a X big B chromosome. I have to do the X's for this one. So assuming that these two actually did disjoin like we wanted, we got the proper results that we'd expect. Meiosis 1 went off without a hitch. Let's investigate what happened if non-disjunction occurred during the phase of meiosis 2. So metaphase, once again, we have the X little b. And in anaphase, a non-disjunction, what would that look like? If our spin was 27 times.
You have two copies of each, so that X, or I guess big B would stay there to the left or wherever, and then we'd empty.
Exactly, yeah. So, no, you're perfect. The point of anaphase is to separate sister chromatids from each other. So if we don't separate the two, we don't non-disjoin, then we don't even separate the
I think what trips me up for this is I have to draw the squiggly lines. It's so dumb, but like, yeah.
Well, that's what is not happening. Because what actually separates.
Oh, they're stuck
is
still
when they're
together.
pulled together.
Okay, that's right, okay.
So if they're not pulled together, then they're still.
I just need to slow down.
So the non-destruction could happen in either one.
Yes.
Well, what we're proposing that it's happening in both, and then seeing if the results create this condition. And then we can identify, yeah, either way, it would still be in a phase of meiosis 2 in the mother. And that's all that's all the information we need. So this would create a telophase with nothing, and then B telophase, nothing, and this little b. This would create a non.
Two empties.
Two non-genotypes. X.
Not be just
It is okay to draw it like this. And that's what we're going to end up with, because these are then going to be incorporated into another. This is going to combine with the father's gametes and create XB, 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 Y, for example.
self-claim.
Kleinfeld syndrome. Exactly. But that's not what we're looking for here. So this doesn't match, this doesn't match, this doesn't match, nor does this. So we investigated the mother, non-disjunction didn't happen, could not have happened in any of her annotations. So that kind of gives us the answer. But let's see where in the father it happened, because you might be asked, for example, you might be told that the father had non-disjunction, and then you have to investigate whether or not it occurred in meiosis 1 or 2. Should I, or it's, let me redraw.
Picture of this. What, I'm gonna take a picture of this.
I would say I didn't, like the way that I thought about it is probably the way that you were talking about earlier, it's just about what each parent has to give.
Yeah.
And if we're looking at the two parents, the only parent that had an X with a little b was the mom. So therefore, if they got that chromosome from their mother, the non-disjunction had to happen in the father because they didn't get anything from that.
Exactly.
if you didn't catch that, you don't have to, I recommend doing this strongly, but you don't have to the way, like I could instantly see the answer because of what Rebecca said, that the girl has this, and we have to think about what the parents can give. So the girl has a little b allele. Father doesn't have any little b alleles to give. The mother has one little b allele to give. So because the father doesn't have any little b alleles to give, the girl had to have gotten the little b from her mother. Therefore, you'd expect the father to have given something, but they gave nothing, which means that these two probably stuck together and gave us a non-genotype.
Where it
Result.
gets sticky for me is, did it occur, like, when did it occur? Meiosis 1 or meiosis 2, which is where I think that's very helpful when you are working through the entire problem. To see where, because for this question in particular, the answer was there's not enough information to tell. And when I see that on a test, yeah,
Yeah, that's what the answer was.
and when I see that on a test, I'm like, that's not the right answer. Like, that's a cop out. But it's
That's just what I immediately went with.
I'll tell you why when we get there. Hello, Palmer. We are investigating question two on the
the practice final.
on the practice final. I haven't looked at it, so. Yeah, okay. So we just determined that non-destruction doesn't happen in the mother. We did that by we made sure, or we looked at what would happen, what would result in non-destruction happening in the anaphase. And we matched the result to this. And if there is a match, then we know that's where non-destruction happened. But if not, like we know, then non-destruction didn't happen in either of those methods. Meiosis is meiosis. So now, just for the sake of completeness, we're going to investigate the father and see if we can find which of the meiosis cell cycles non-destruction occurred in. We're talking father time now. Father has this. So we know once again, this is one. Phase father is baby Y. Phase A and Y in the center in their homologous pairs. Remember, these are sex chromosomes. Chromosome number 23 in humans today are homologous to each other, so they align next to each other during metaphase and then anaphase. So what would a non-disjunction look like in anaphase in the father?
BY on one side and nothing on the other.
Exactly. Once again, non-disjunction is two things that we expect to disjoin, not disjoining, so they stick together. And this would result in a toe. On one side, nothing on the other. So we create two cells. This would create a non-genotype, and this would create a genotype of X. Y. X big Y would combine with the mother's X little b to give X big B, X little b Y, which is not what we see in the child. Or the father could give a non-genotype, which would combine with that X little b to give X little b. So this is a possibility at long last. That is a possibility. If you remember what we just did with the mother, you'll see why we can't really know for sure. So we now investigate meiosis 2 to see if it was also possible in meiosis 2 prophase, assuming that meiosis 1 went off without a hitch. We're going to investigate what happened in meiosis 2 with the father, if not sure. So let's say that these did separate properly and you end up with a B and a Y. Anaphase, however, anaphase. What if non-destruction happened in either of these two cells? What would that look like?
So that's why it's not possible to tell, because it could happen in either one.
Here or here or here. So let's just follow the process. So what would, it's kind of weird, kind of like split this Y. So if I would draw an anaphase that actually went up like we expect, I can draw the Y.
Oh.
Because it's weird to think about it, but the Y is not just made up of one bifurcated chromosome. It does separate in anaphase usually.
I drew it wrong though, one time.
And yeah, you guys already see it, but just for the sake of completeness.
So I mean, technically, if this was like a short answer problem, would it be wrong for you to say it's possible to happen here or here?
You could say,
If she's looking for the answer, not able to tell,
and that would be perfectly accurate.
but if it's multiple choice
If it's a multiple choice,
and there's multiple answers, just go with mine.
So does non-disjunction only happen in anaphase?
it's
Is there a
in,
reason why?
it's in the name. I will write it third time. So
It's
Oh,
where they separate. So
well,
when they're
oh,
separating.
so not separating.
it's
Yes.
It's not. Oh, that makes no
places
sense.
where they separate is in anaphase.
Okay, and so
Word roots.
so it happens in the male and not in the female, like specifically because of the fact that the male can only give one X. Is that a decent reason or?
The reason, so in the question, we were given that we were given the child's phenotype.
And it's only X little b, that's it?
Yes,
only.
they're a Turner syndrome individual,
There's probably.
and they have color blindness.
And so they only have one gene or like one allele.
They only have one chromosome, and the allele on that chromosome is the color blind.
Because think about like if they had a colorblind normally they could XB, so they're not a show. So that means like they have to have one in order to have like one.
And so we were given the information to determine this child's phenotype, and we see that there's, they have a little b. The father doesn't have a little b allele to give, so we know that it had to have come from the mother. So that's a good shortcut. We know that the mother did give only this little b allele, but the father didn't give anything because they only have one chromosome. So it's pretty obvious that it happened in the father. and it
Yeah,
resulted in this.
Because if it happened in the mother, right, we'd have to receive that X big B from the father, right? Which we clearly didn't because we have X little b. So we had to inherit X little b from the mother. And if we did that, then non-disjunction didn't happen. If we did, we would have got X big B, X little b.
Goodness, I better myself.
Gabriel McLeod already.
I finished my paper. So like the way that she did it, she was like, it's single spaced, not like 1.15, which is like the normal, it's single spaced. And it wasn't based on like how many words per section. She was like, oh, this section should be like at least a page. And so it's like at least a page, but single space.
Yeah.
So it took me forever to do. And then
I always
I had
mix
to
up
put
my
the safe aside thing where like it checks
Oh.
pages and stuff.
He looks
I was so scared.
so
If I get like
blast through
anything about old things of time, I'm scared. But I got 10 exams.
blasting.
Oh, really? Oh,
So like, I got that one.
We're almost done.
It's the one that goes out to fragments. The one that goes.
I don't even have one. Why do you want
Limeric's
one?
Limeric's 3.
Yeah.
What is it?
Wait,
It's the one that adds to the nucleotides.
Yeah.
So
And then. Yeah. I think I'm good on this one. Thank you so
I
much.
agree.
And I had it written over there, so I'm gonna just erase. Thank you so much. Although.
I didn't do 2C though. Sorry.
No, that's 2C.
Really?
Is to determine where.
The
Like where the
non-disjunction.
non-disjunction occurred, which the answer was, we don't have enough information. When I see that as an option on the test, I always feel like it's a trap. Like, that's what I would guess.
What's the situation where you would have enough information to know where it happened?
I would say if you have something like Klinefelter syndrome, where you have
Yeah.
XXXY, or something more than just one chromosome.
So if you,
We're told that
you were at not a girl, but a boy, that's reduction spot, and there. This isn't Klinefelter's. This is,
I don't know what it is.
I don't know, there's a name for
But
it.
I know
Which
Dr.
one?
Bell always does either
XY
Klinefelter's,
low.
she does Klinefelter's or Turner's.
No, it's
So-
not Turner's, oh my god. I know what it is.
This is Turner's.
Edwards syndrome?
I don't know.
I think it might be
I don't think
Edwards.
we'll get tested on a
Yeah,
non-disjunction of Y.
But if this were the case, well, then it would be pretty obvious that it's the
Definitely.
father, because we have two Ys, the mother can get none.
But we still wouldn't know where it occurs though.
But if you were
Jacob.
Jacob, that's, we did talk about that, okay.
Jacob and
If it were X, little b, X, little b, X, big B,
Oh, Edwards syndrome is N40.
who would it be? Where did non-disjunction occur? Little b, X.
And non-disjunction of Y.
Why?
Because she's the only one who can give the colorblind gene. And would the child be colorblind? Yes, no, because they have.
It's
a big
possible.
gene, a big-
It's possible
What about-
because of the gene
Dosage.
dosage. It's possible.
But there
But,
is that
yes.
natural selectivity where
That is
I would
true.
assume that the body would say, oh, nah, we want to see all the colors.
Could they have
so-
partial colorblindness?
Yes,
Because I know colorblindness is a
and that's
spectrum.
right.
And
Wait,
like, there's that thing where.
why would
it's
it be in the
every cell
female there?
has
Because if
chromosomal
we
silence.
do it in the
Yeah,
female,
so
right,
that's
you
what
have
we're talking
big
about
B,
with
little
the
b, but then where would you get that
versus
second
not.
little?
It never separated, so it carried on.
But sorry to interrupt.
Oh, no,
For
no,
the same
sorry.
reason, the father only has big B alleles.
Correct.
So when we do it out, there is no situation in which you could also get a big or a little b.
Right, we know we can only get little b from the mother, but how do we get a second little b?
Yeah, I think you were not here yet
No,
when we talked
Not
about
for the mother.
if we do -1 again for the mother, we have, hers was big B, little b, so yeah. They're homologous to each other, so they're in the center, and then we have anaphase. In anaphase, oh wait, no, the B in -2.
Yeah, they both split to the same side. For meiosis
I
one.
think we'll need to know the probability.
Yes. Yes,
Garrett would know, he took the
Very, very
exam.
well.
yeah, so this would then.
Well, I think you can see it.
Well, yeah, I already
Yeah,
took it.
yeah, also.
Like he took like our test. We're supposed to
Oh,
take.
when did you take?
He got like 103.
Get out.
Monday, Sunday. Then what we'd see here is a non-disjunction. These are just spindle fibers that are drawn here. We have non-disjunction, so they don't separate. Like these.
What are you doing?
What are you doing?
How was
Yeah.
yours?
It went fine.
How's yours?
It went fine.
How was yours?
I crushed it. Yo,
You guessed it, right? You guessed it. Yeah.
I crushed it.
Yeah, you did?
I did. I'm almost certain. And if I didn't, I still did better than the rest of the class.
Sure. Here.
People were like, in the Discord, they were all dying. Some people are like,
Yeah, but
Yeah, was that a red mark for here or did you have it? I think it's mine.
oh,
I lost mine, that's the thing. I
Yeah,
lost
that's
my red
badass.
marker.
no, I think you gave it to me that one morning. and it-
It died.
it died. Remember? We threw it
No,
away.
that was my blue marker. I now have a red marker that we were using to write, to study for.
Oh,
exam.
yeah, I remember that.
Yeah. Where'd you go?
It had to- maybe Bernie had
Did
it,
you take it?
and I didn't put it.
Did you take my red marker?
Why would I think that's yours?
Was Sean?
Do you remember consensus?
Keep going, keep going. So how do we get to it?
Later.
So if this happened, what we would, so this is anaphase, this would be non-disjunction if, assuming that meiosis one
Yeah, this is meiosis two.
went off without a hitch and we ended up with the proper results of meiosis one. in meiosis-II, looking at both possible cells, this X big B would not disjoin, the sister chromatids would not separate, or the X little b would not disjoin or separate. And so the result of that would be one empty cell. Because we have telophase with the empty one, and we have the empty one, and the X little b, which we also show as two sister chromatids being X little b. These would give the genotype of X little b, which would combine with big B that we got from the father.
So like before when we, okay, but if we make that assumption, why couldn't that happen with the male before?
The male has no little b to give.
Not the male, I'm sorry. When we had only X little b before like the original problem, then like, doesn't that happen then? We have X little b, X little b?
Could get this, could get this. This gamete could combine with the other parent's gamete.
Okay, but the other parent's gamete's a male.
Yeah, that's why we know what happened with the father, because.
Never mind. I didn't switch on. I forgot then the other one. The male has not the structure, not the female. So we get the little b from the mother, and then all the structure happens. We get the zero gamete or zero allele thing from male. That's how we get X little b. If you want this, then it has to happen from the female. Gotcha. That makes sense. But like if they're two squiggly little b's, why do we get two X's? Do they just duplicate?
Must.
Do they just duplicate to make X's?
We have two sister chromatids here. They separate from each other, but they don't migrate to different poles of the cell.
But why do we write them as X's?
It's easier for me to draw.
Okay.
So they end up as being this, and then these sister chromatids
Yeah,
contribute this.
because they're both chromosomes.
How would you determine if it happened in meiosis 1 or 2? If it was possible to tell, you would not be able to tell because it could. The only thing that we see is that this offspring did not. Yeah, the only thing that we could see is they have Turner syndrome and they have color blindness. Turner syndrome is having just one X chromosome. This is all we know. This is what they have. Sorry. And what we know is that they inherited a non-gamete from their father. But we don't have enough information to tell whether that non-gamete came from meiosis 2, from the lineage of the BP, or from the lineage of the Y, or if it happened in meiosis 1. Either of these three are possible to have given us this genotype, and we just don't have enough information to tell. So it's not possible to tell, would be the answer.
So I do have, I don't know if we want to go through another one. I'm so sorry. I know it was pretty lengthy.
No.
But on exam 2, question number 16, in that one, we can determine if it was mitosis 1 or mitosis 2. Meiosis. Sorry, meiosis. I'm sorry. That one, you can't. Huh? Okay. Do you want to go through it again? I took a picture of it and I can also pull it up. But I started writing it there. This, oh, you have a question?
I'll probably do it. It'll probably be like.
This
fascinating.
9-3-4 ratio in residency homeostasis, is that the genotype frequency? It's gonna be
They have
after.
so much, they have so much time today.
I know, but it's. I'm gonna assume it's the genotype.
I don't know, it's like,
So the 9 to 3 to 3 to 1.
I don't care.
also have the nine is
I know you do.
dominant allele of the first sequence.
Like, the only reason I'd ever do
The other three are dominant first. The other three are recessive.
Did you sign up for that?
Dominant second, the others are recessive. So these were just combined. Because, if these were to combine, this dictates
I
the
don't-
phenotype or phenotype. They're still different.
I just didn't get the.
Right, so look, this is
You, Dr. Orr told me.
She hasn't chosen.
I asked her yesterday.
What'd you say?
I was like, have you chosen your? She's like, yeah. I was like,
You just told me she didn't choose. You just told me she didn't choose.
Sorry for.
Or not.
No, it's okay.
Oh,
Yeah,
Wait, wait,
well, we could, if you want to ship this, I have the eraser. I'm so sorry.
In case that just.
I do that too much.
I do the test.
I
we'll
will.
open up at 7.
Again.
Wow.
Okay,
But you have until.
so this is the problem. I can bring it to the,
But like, I took it then, but like, I don't know, like, give it to you, but like, everyone's there, so I had to think there's so. Like,
so I started writing
yeah,
like.
I'm trying to look at the syllabus
Yeah.
for this class, because I want to see how much.
Yeah, how about you demo this question?
Oh, I can try. Okay.
Do you want this?
Yeah.
And you can have any of the color you want. Can I erase this?
Okay. So this is question 16 on exam 2. And I'll go ahead and, I'm gonna go ahead and read it if you guys don't have it pulled up. Tony has Klinefelter syndrome. His father has normal colored hair, but his mother has a rare genetic disorder that leads to abnormally colored hair, an X-linked recessive condition. Tony has patches of normal hair and patches of white, coarse hair. Using A to denote the normal condition and little a to represent the recessive condition, what would Tony's genotype be? So the first question is, it's asking Tony's genotype. So we know that the mom has this genetic X-linked recessive condition. So the mom is going to be X. I'm just going to do C, little c, little c. And I think the father has normal colored hair. So we have big C, Y. So Klinefelter syndrome is, for Klinefelter's is like duplicate X's. So it's gonna be XXY. So my thought process when I think through, oh, I got this one wrong. So yeah. Okay. So for A, this is where I'm kind of, like, I got it wrong. So my thought process was that because they have, at least that's what my thing says.
Sorry, I was paying attention. Could you repeat what the different alleles?
Okay, so the alleles, let me use A. I'll just go ahead and use A because that's what the answer he has. So it's an X-linked recessive trait. And this is where I'm stuck. So the way that they describe Tony has patches of normal hair and patches of white
Oh,
coarse
I
hair.
remember this question.
So I'm starting to think it's like a codominance. It says that it's X-linked recessive, but I guess it's dominant. Not dominant, sorry, codominant.
Can I see that?
Is it not? Because it throws me off. When I was doing it, I'm like, why is it
Patches of
not?
normal.
He has patches of normal hair and patches of coarse hair.
What other sweet furry little friend do we know that has patches of different colors?
Our tortoise shell cat?
The X thing. Where in every.
What's
like,
that called?
one X is silent. Who's the name for it?
Female mosaicism. Well, it's
Oh.
called gene dosage or dosage compensation, but
That was a trick question.
in different cells, different X's can be turned on or off. And that shows up
Oh,
as a mosaic, a patchwork of colors.
it's because they have,
Oh, they have
because they have two X's.
Klinefelter individuals benefit from female mosaicism.
That makes sense. Okay, so. Okay, so that's how we'll, okay, cool. So the first question is, it asks for, one second, it asks for Tony's genotype. Knowing what we know now, we know that he has a big A and a little a. So they are heterozygous for this condition, which makes sense. So the only person that can give the mutant chromosome, I'm sorry, the next question is, let me find my place again. Tony received the mutant chromosome from his insert mother or father. So the only person that can give the mutant chromosome is X-linked recessive is the mother. So boom, we've got the mother. Non-disjunction occurred in, who did it occur in and when? So at that point,
Just right now, can you tell who had the non-disjunction? Think about who can give what.
Okay, so
Probably dad,
it's
honestly, dad.
yeah, it did. So like without even having to go through it, mom can't give an A or a Y. So it was the father. And where, like when it occurred,
Now you gotta draw it out.
now we have to draw it out.
Well, I know.
So I'm sorry, I just repeated what you said, so I can repeat it to myself when I
keep
do
going.
the test.
And I'll
Okay,
give you a trick when you finish.
okay. So we know it's in the dad. Let me.
Can non-disjunction happen twice? Like, it'll happen in meiosis one, meiosis two?
Oh my God.
Okay, so then it happened twice on the father, no? Oh,
Okay, so.
Well, no. I heard this morning.
So I know what the answer is, but that doesn't mean that it's right. So in prophase, we have two sets of your X's and your Y's. Metaphase, they'll be separated. Sorry, let me draw a circle here.
I'll give you a trick.
So XA, Y, telophase. Okay, so that's what it should look like. But if disjunction occurs, then we will have XA, Y, or nothing. So this is meiosis one, then meiosis two.
You may as well take it. Wait, just so
Yes.
you drew the proper result.
I did, I mixed it up. So this is the proper result. And then this is if non-disjunction
Okay.
occurs at anaphase, this is the end result after cytokinesis. So an empty one. Hey, heck yeah, girl. Thanks, guys. Okay, so in prophase one of meiosis two, we will have XA. Oh, wait a moment. Am I doing like, I'm doing two concurrently, right? Because they're different.
Yes, but just before you move on to F, what I like to do is look at the end results
Okay,
of meiosis one, which you created, and compare that if they, oh, no, not those, yeah, those, the ones that result from non-disjunction. Compare those and see if, when combined with any of the other parents' gametes, would produce the Tony's genotype.
okay. So we know Tony's genotype is X big A, X little a, Y. So the mother will give the XA, leaving X big A, Y, which the father can give after meiosis one.
So that's a possibility.
So that is a possibility.
Now we need to see if it can also happen in meiosis two.
Okay, at which point we don't have a duplication of Y, so there really is no need to go through Y. So we have, where did I write that? So we have XA, at which point first we have prophase, metaphase, and then anaphase. I'm just gonna like draw it like that, half the X. That's also A. Oh, sorry. That's a very ugly
Don't
circle.
worry about it.
And then for telophase, we're gonna put that down here. Looks like a pumpkin. Anyways, the end result, if it's properly
That's how
done,
I found it.
that's what it would be. But if we had, let's say we had non-disjunction occur at the anaphase, the end result would be 2 copies of A and an empty cell. So we only have 1 copy of the big A. This has 2 copies of the big A. So that's not what we're looking for. So it'll happen in meiosis 1. Thank you. Thank you. Oh yeah, go for it. I think we
Great
have,
job.
oh,
That was
I didn't.
perfect.
Thank you. Oh my God, I better get this right on the test. If there
Heck
is
yeah,
this
you
question
are.
on the test, better. Does that make sense? Kind of, sorry.
Perfectly done. I couldn't have done it.
Great. Thank you.
Or you can have me to be here until like 4 p.m. I was like, oh, it was like, oh.
Transcription. Just because there were some things that I can't remember, like some of those two questions that she had on the test. I just genuinely like,
We can, for your exam. we can
Okay.
go through one.
yeah, like there were just like little things like the promoter versus an enhancer. Totally thought that the Tata box was a palindrome.
I thought
Not
it
it.
was a promoter sequence, and it was not.
Tata box?
Consensus sequence, which
Yeah,
first of all, I think it's also tricky, because it's be a promoter.
This is why
sequence.
I did that on that test. I got a bunch of those little 2-pointers
Yeah,
wrong.
yeah.
That's part of the arts.
Guys,
Which was it? Wasn't it art?
can I share my achievement? My achievement is, I got this, my two is my first question completely wrong on this exam. I answered the question, I got all completely right. This is like super duper helpful. 0 out of 8 in this question. Look at that, X, 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 X. That hurts my feelings for real. 0 out of 8, just test number 1. And look, I just did it, they're all just. Are you guys gonna have that? No, I'm not. No, I'm good, I just, sometimes, look, C is.
Do I want Chipotle or do I want zero?
Just like I always recommend. So it's spelling, it's healthy, prayer, never gives good portion sizes.
I should go over my test. This will be the first time I ever go over my test. And I've never checked my test on track ticket, nor homework for any assignment.
No, I don't do that for ortho, and I did it for exam 4, because Jazz was like, yeah, I got that question wrong, and I was like, I should probably, I never do that for my ortho exams.
I tried to.
Because it hurts, it hurts, you know?
I mean, as long as I get a good grade,
Physically.
I'm like, I'm good, like, I'm happy.
Here, 'cause I thought the final would be different.
Mine were hard.
No.
Final
for
was-
this class,
No, it wasn't hard. It was
I
fine.
know I
Because
failed, but I
only got
got,
this because
like,
got
I
it wrong.
understand, like, these are kind of sort of fair questions, except some. Like the enantiomer, some of them were, because I'm like, we would have this. But this is really.
The Newman
hard.
projection when it was like an answer. That was how it
It
was.
was dumb. That one was annoying. I got the enantiomer excess question right.
It was a Fisher, not Newman.
No, I got a
Oh.
Newman projection.
We don't see that.
Yeah. So,
Isn't Newman projection all the circle?
yes. No, the
Yeah.
Fisher
Yeah.
projection one, I don't know if I got right. I have no idea.
There were
I
like
don't care.
3 of them.
Yeah, I know. Some of the predict the product ones, I like totally messed up.
I was like 4 steps. I was like, oh.
That's too much. Yes, 25%.
I just picked picked between the two that look the closest.
We
Usually
do
that's
do
how-
that.
That's usually how it goes.
Yeah,
So
yeah.
you just 50-50 at that point.
Do you have process elimination? Do y'all remember enantiomer excess?
No.
It
I
was the
saw that
difference
one.
between the two. It was like 26%.
Not wrong.
It was 26%. I got that one wrong.
I just guess, I'm like, it can't be either one of them, and it can't be 100%. So I'm gonna guess. See.
I thought I just picked the percentage of the major one, or like the first one, which was 67. I think.
This question sucks. Dude, all I need is like a 60% to get it.
I mean, I think it'll be curved by like 20 points.
Wrong.
I hope so.
So I wanted a 50. If I get a 50 and it's curved by 20, I get a B in the class.
I never thought.
Did you enter it?
By the-
I'm not an institute.
I was
didn't
not
feel
a
like
D student. First time out. I got plenty of C's. So here I am trying to fix it. And it's much harder to fix it when you're really not good.
That's my grade right now in class. Oh, that's not good.
What?
I have 82.5.
In what class?
I did agree.
Oh.
Yeah.
Okay, I feel much better now.
Yeah, we all did like pretty similar.
Yeah, we
You're
really
like
did.
84.
Amazing.
No way. Oh my god, guys, what is wrong with us?
I don't know. Where are we at?
Wait, this exam matters now, no?
Exam 2. Question 11. Here. We have a question in the chat.
You know the answer, Jasmine. Answer.
I do, we did
Yeah.
do the question, but I'll let the expert answer it. You had a question about this question.
Exam 2
11.
question.
So the same one we did this one.
No problem. Yes, so. Um, So let's say. So you have genes A and B. They're 22 map units apart. What are the correct frequencies that this flag could make? So what this is really asking, poorly wordedly, is like out of the possible offspring that could result from a cross between individuals with these genotypes, what is the proportion that every resulting offspring genotype will be? I didn't word that properly, but if you have this parent crossing with this parent, they have it. Capital A, lowercase b, crossing with lowercase a, capital B. When these two mate with each other, they're going to produce like they're going to produce offspring, or they could possibly produce offspring with specific configurations of alleles. And so this first parent with a capital A, lowercase b, could give their big A, which would combine with this individual's big B, or the big A could be with the little b. The little a could be with the little b, or the little a could be with the big B. So these are the possible genotypes that could result from a cross between these two individuals. And what it's asking is, what is the frequency at which each genotype, each offspring exists, based on what we know about the distance between the two genes A and B? And what is a map unit? What does that represent? Obviously, map units are distance, but what do we use distance to approximate when we're talking about recombination?
The likelihood of crossing over.
Yeah, likelihood or the frequency of individuals. That's okay, you don't have to say. Yeah, we use map units or distance to approximate. Actually, we use recombination frequency to approximate distance. And the reason why is because, I hate trying this. If you have two chromosomes, we have big A here, little B here, little A here, big B here. The closer these are together, the more likely it is that at any random point on the chromosome, the crossing over were to happen there. So if it happened right here, these two would switch their arms. So you have that. And these two wouldn't recombine. But if you had it, even if you had it here randomly, they still wouldn't recombine. A and big A would still be with little b, little a would still be with big B. But that's because they're close together. The further these are apart from each other, let's say if big B or little b was down here, then when they crossed over, the little b would be separated from the big A, and you'd show recombination or a non-parental genotype. So we use map distance, we use recombination frequency to approximate map distance, because the closer something is together, the less likely it is that they'll be separated when recombination of the crossing over occurs between two different chromosomes. I'm talking so fast that I did.
No.
What's that? Okay. So what we do is we're told the distance between A and B. It's 22 math units sent to Morgan's. This indicates that the frequency of recombination between the genes A and B is 22%. So 22% of all the offspring will show recombination, will show a genotype that is not the same as the parents. So if these are our parents and we had recombination crossing over between A and B, we could see that this big A would come down to connect with this big B. So this one. And this little a would cross to be with the little b. This one. And if 22% of the offspring are that way, then big A, big B plus little a, little b is 22% of all of the offspring. And we assume that it's random whether, because of meiosis, it's random whether or not we end up with this cell or this cell. Oh, I'm not sure if you can see. Because of meiosis, it's pretty much random whether or not this cell or this cell from the father will swim its way and meet with one of the gametes in a female. So similarly, we assume, we assume that it's random whether or not you get this combination or this combination of recombinant gametes from this cross. And because it's random whether or not you get this one or this one is just as likely as the other to happen. So we take the total frequency of these individuals and divide it by 2 because it's just as likely to get this one as this one. So if 22% are these two, it makes sense that 11% are these and 11% are these. And you could take it further. We know that these are 100% of the offspring. So if gene locus A and B are 19 map units apart, what are the correct frequencies? Some of the gametes that this fly could make 19 divided by 2, assuming that they're still in trans. No problem. So if gene locus A and B are 19 map units apart, what are the correct frequencies of some of the gametes that this fly can make? It's the same process. We know that this is no longer 22, but 19%. This is in trans, by the way. And that just means, we talked a little chemistry earlier, but that just means that you have different alleles. You know, if you're thinking of wild type individuals, you think that at a single locus, their diploid genotype would show as being wild type. But sometimes they can be in trans where they have a wild and mutant type. And they're in trans just because the alleles have different chemistry. You can't forget that all genes are just molecules and they interact with each other differently. So they show up in repulsion, we call it. They repel each other. They're different across one individual and the other. Like you have a dominant and a recessive, where you usually expect to have a dominant and a dominant. And you have a recessive and a dominant, where you usually expect to have a recessive and a recessive. So that's why we call it in trans. It's not what you'd expect. And that's why these individuals, capital A, capital B, lowercase a, lowercase b, are the recombinant. Because when recombination or crossing over occurs, you get away from having individuals with 2 different kinds of alleles, one dominant, one recessive, and they now have both dominant or both recessive. So the 9.5, if we did this math just a little bit differently and this were 19 instead of 22, then we just have these two being 19% total. And because one is just as likely as the other, we split that 19% evenly between them. We do that by dividing by 2. 19 divided by 2 is 0.095 or 9.5%. And the remaining 81% would be split evenly. Yeah, there you go. Just a wee bit of math. You're so very welcome. And I will try to be better about monitoring the chat questions. Thank you guys for coming and hanging out with us. Bye. Thank you. Thank you. Best of luck on your exam. You can do it. You're a champion. I believe in you.
Are you busy?
We actually went over a similar question, but I think you went before.
Which one?
It was the figuring out why the son will have a 0% chance of getting the same genotype as the parent.
I don't. Bye, Josie.
I'll be right back.
You're not gonna see me, you better sprint back. We're not gonna see you tomorrow. This is our last time together, guys, this semester.
Right, is this your last final?
Yeah. Is this yours?
She has her conservation.
How about you?
Can you teach me?
Yeah, I can send you all the tickets. Do you want the back?
Just like for you to get a chance to talk about it. I
Show me
think
the
just-
map and I'll leave you.
do across your- Across your-
I still don't like that question, Garrett. The one that's like, what are the chances it won't, the kid won't look like either?
That's what I'm doing now.
I know. I
We did
asked
that
that question because it was,
I put 0 down.
Do you think that's?
it's the first time, it's like, what's this? It's like the wording. Is it either like I can look like my dad, but I won't look like my mom, or I can look like my mom, but I won't look like my dad, like.
Because the thing that tripped me about this is that, is that the parents share multiple phenotypes, right? Like they both, for example, have little c, and little c, little c. And that's the case where like the kid is gonna have little c, little c. So therefore it's 0% because they're both gonna have little c. So they phenotypically resemble both parents.
So I've only had this.
I know, but for the other alleles, it's like. Okay. But then, okay, so how would you do the math for it then?
So you want to find the probability that find the probability that it's both parents.
So like mom and dad. I found phenotypically as dad, now it's my phenotypically as mom. That way it's better. Yes, dude, got it.
This is the same.
That's the same, yeah. That's the 1/4 again. And this is all the same. You think that's the answer? When are you going to Florida? I'm going to Florida. I'm going on Sunday. Where are you going? No, Orlando. We're going to Boca Raton. Oh. I'm going to this family.
Potential future guest.
Oh, that's cute. Are you gonna propose? How are you doing?
So,
Don't get a financially stable job. We'll
What's
move
up?
up from.
What does she want to do?
She's studying some
Her.
It's just 44. 44%.
That looks really cool. Looks like you're gonna pass your space on that. This is me just popping my notes. This is you manifesting. I love it. It looks great. Oh. Oh, you're kidding me.
Oh, the other way. Yeah, it's the other street. Both are good.
I got it. I did it. Yeah, that's the answer. Isn't it? Okay, so the letter C asks you to find the probability of the same phenotype as dad. Okay, then what you're gonna do, D, is you're gonna find the probability for the same phenotype as mom, add the two together, and whatever's left over is gonna be neither. Cause like, you either are like totally mom, totally dad, or neither. So that's the matters. They actually have the same probability of getting either, which I guess is, yeah.
So like,
Cause like there's like
it's for age, it's
six,
1.5.
yeah, remember you did 0.5, look at that, you did 1 half. And then I did 0.75 instead of 1/4, because that's like the other,
That's the other.
yeah,
That's
and then-
just the one.
yes.
Yeah. One.
Yeah, exactly. And that's the phenotype for mom and dad. Did swear. Yes. You also explained it last night, but yeah. What is it, 9 over what? So then, and then with dad, we figured out that it, let's say you figured out. Okay, so times 2. 6.2.
One minus.
Right?
You don't get some level first. I could never. Fuck, that's not- Oh, yeah.
Be Jasper.
Other was-
We talked about it.
What?
About what?
We were just like, yeah, Bernard isn't here, he couldn't come.
Oh, wait,
Dr. Bell, yeah. Because it was Dr. Bell's event.
Oh, I wanna talk about.
But also like, I don't care what I can. I'm sad after working Tuesday. Are you sad?
I understand,
Are you sad? Why is that? Who did she choose?
but I mean, she went from having 8 hours to 4,
Oh, so you think she like,
so like, her choices were a lot less. And like,
oh, I just ate one, but then
it like, I actually ate one as well, I'm not even kidding.
that's my ate mine.
Yeah,
Yesterday during the ACS exam, she was like, you're allowed to have a snack. And I was like, Bernie, I'm gonna get you a snack. And I actually eat the snack during the test. No. Bernie thought.
it was more exhausting. But yeah, so, I don't know, she probably picked like maybe 10 actual majors.
I don't think so. I think Farah also applied for Orgo once.
Did there apply for it? Okay, then that's one spot on. So,
No, but we don't know if she got it.
I mean, you probably did. I mean, I wasn't.
Was it you?
Yeah, you know me, I love work.
So I don't know. She was.
Did you take your final yet at Orgo? Your ACS? How'd it go?
For people,
Such a smart. You can be good at genetics and ortho and anatomy. You pick, okay?
I think, yeah.
You're really good at
wait, I have a question.
You're-
So I missed a question.
it. Where? This or this? That? No way. Those are my toes.
No, it's your foot.
That was my foot. My brother broke his fibula.
Fracture.
You know what fibula is? Yeah. It's just-
Was he fractured this?
Yeah.
Oh.
I told you when he jumped, he landed like that.
Don't show it to me, please. I hate it. It's like I feel it in my soul. When people show me stuff like that, it's like I
I didn't
feel
show
it. It hurts. It's
I didn't show you the actual like thing
I don't
happening.
no, but like just like see it like oh my god.
Yeah, it was his full body weight on it, his full entire body weight.
I don't want to know anything more. I don't wanna know anything more. I'm done. Or here, go.
He's like 5'8", and then he's like,
It's like what? You can tell he's like 200 pounds.
he's not doing it. He's really skinny.
Oh, he's like 15.
Yeah, but he's still a skinny
I
boy.
know. That's what I'm saying. He's 15. He shouldn't be.
How are you feeling, love? Like, I might as well just go get it over with. Are you gonna go now? Yeah. Oh, there's probably a wait, but. No, I just walked past, Oh, really? Before I came, but nobody was outside. And the cubbies looked empty, so. That's kind of surprising. It is. I was expecting it to be like super busy. I think it's like either the morning shift is gonna be really busy or like the late. Yeah, I feel like after like 2, it'll probably be busy. Yeah, maybe. But I'm probably gonna take it after 2, so.
I was gonna take it at 9, but I didn't get up until after 9:30.
Yeah,
so-
I accepted today.
Yeah, I did. I wake up from home.
I woke up at 9 when I woke up.
I need to borrow a brain. I need some.
You got it. You got it. You got it. You got it. You're amazing. We were singing phone, I think.
Is it the
13.
yeah?
Oh, I love your case.
You're gonna crush it.
Good luck.
the
You're gonna
best.
do amazing.
Stop.
You guys have more hope in me than I do in myself. No. Listen, you're gonna ace that shit.
You'll do fine.
You're
It's
gonna
more
do great.
basic, so
Okay, Bernard, let's be encouraging.
that is encouraging. I'm telling you,
Bye.
it's gonna be easier than normal exam. Wait, yeah, I have a question. So apparently on the syllabus, it stated that the exams were 60% of this course grade. Well, do you want to read it with me?
Yes.
I want to know how much percent this exam is. Is it just evenly split out?
Yeah.
Or like, so here's my thing. Dr. Bell was like, if you do better on your
Yeah.
final,
Yeah.
like
Replace.
replace one of your other, does that mean like you'll have 2
I
of
will
your final
try it
exam
out
for
you.
it? Is that what that means?
Yeah.
That's all that means?
Yes, exactly. Yeah. I'll have 2
Dude, I
final
thought
exams.
like I was still confused even after you told me about it. I was like,
Is that a
oh.
handkerchief? How cute is a handkerchief?
So if I get like an 80, it'll replace my 76 with an 80.
Thanks
and
for
then I'll get
hanging out.
another